So very good morning to everyone. I, along with our co-coordinators, Dr. Santosh Chaudhary sir, Shri Suryakant Kulkarni sir, Professor Ushkewar, all my colleagues at GP Nanded, we all welcome you, all our respected participants, and our honorable resource person, our honorable speaker for the first session, Dr. Tated sir has joined. Dr. R.G. Tated. Sir, can you hear us, Tated sir? Can you unmute your mic, please?
Yes, I am able to hear you.
Yeah, so should we start the proceedings?
Yes, sure.
Are you ready? Are you ready? Yeah. So,
I am ready.
yeah. Thank you. So, good morning, Honorable Tated sir. We welcome you on behalf of our institute and on behalf of the organizing committee.
I am ready.
May I tell all our participants that Professor Dr. Tated, R.G. Tated, he is a technical advisor at SNGB's College of Engineering, Sandwad. He is a very senior industry consultant, an industry advisor, and a well-known trainer. And he is invited on various fora to deliver expert lectures on various topics. He is a very, very versatile speaker, and he likes to interact with teachers. And this is his second time that he has been invited at Government Polytechnic Nanded. 3 years ago, he had conducted hands-on training and in an offline mode for technical teachers during an STTP program related to CNC machining and simulation. And our today's topic is Lean 4.0. Now, Industry 4.0, Lean 4.0, Education 4.0, these are going to be the terms which would be frequently heard henceforth. So, whatever may be the technical background of all the participants, many of you have been from computer, electrical, electronics, etc. But येणारा जो काळ असणार आहे त्याच्यामध्ये ब्रांच स्पेसिफिक पेक्षा मल्टीडिसिप्लिनरी स्किल्सची आवश्यकता जास्त आहे. त्यामुळे आजचे आपले तातेड सरांचे जे विचार आहेत ते आपल्याला मार्गदर्शक ठरतील. So may I request Honorable R.G. Tated sir to begin his session, please. Tated sir, please. The mic नाही दिसत आहे सर. Tated sir. Can you hear me, sir? Oh, आहेत पण त्यांचं. I request Tated sir to unmute his mic and please begin. Yeah. Okay.
Hello. Are you able to listen to me?
Yeah, you are audible and we can view the slides also.
Yeah. Sure. Nice. Thank you very much.
Thank you, sir.
Thank you, Dr. Sakalkale. So I am starting with my presentation, and the area which I will speak is Lean Industry 4.0. Am I audible?
Yes, sir.
Yes.
Very much.
Yes. So we all know that the industry has taken a very wide exposure from last 300 years, and particularly in last 50 years, we see the technological explosion as such. So if we look at the growth of the industry, we can see industry 1.0, 2.0, 3.0, 4.0, mechanization, then mass production, then computer automation, and the cyber physical systems as such. What we talk today about industry 4.0, probably it is reaching to 4.5. What we call it as a dark factory in days to come for. Today, what I will try to have a collaboration of two systems as industry 4.0, which is a hard automation, and another part of the system is a lean manufacturing system, which is people-centric system. Industry 4.0 is a technology-centric system, hard automation-centric system, whereas lean is a people-centric system. And therefore, we'll try to collaborate this and try to see how it can go forward. We know, I'm not expert in industry 4.0 as such, but to some extent, I understand the industry 4.0. I understand industry 4.0. And I am expert in lean, TPM, Six Sigma. So we'll try to collaborate this too. So with data and connectivity at its core, industry 4.0 is about merging of physical and digital worlds to gain analyze actionable data signals. And we know the parts. So there are certain things required in industry 4.0, what we call it as IoT, Internet of Things, augmented reality, virtual reality, cloud computing, cyber security, big data and analytics, advanced robotics, simulation. So these are the parts you are well aware of this, including machine learning and artificial intelligence, what we talk about these things today. What I am going to talk about is what is lean. The system which is originated in the 1950s at Toyota production system. Lean manufacturing is about the elimination of waste. So whatever wastes are there in the system, we need to eliminate so that we can reduce the cost of production. The system started with the observation of Mr. Ono and E.G. Toyota. What they could do, they started in 1950 around, and Ford that time was very wonderful doing. Ford was producing around 30,000 vehicles per year, whereas the 13 years, Toyota could produce 2,700 vehicles. And these people were frustrated for. So they visited the Ford plant, and they thought that they will learn something from the Ford and will implement in their factories so that their production can be improved. When they visited Ford, and what they could see was it was production oriented, mass production oriented system, and therefore they thought, no, that is not useful. Some of the part they could get about, but while returning back to Japan, they visited one mall, supermarket, and that was Piggly Wiggly. So when they visited Piggly Wiggly supermarket, they could see many things there, and from that Piggly Wiggly supermarket chain, they could learn many things and they implemented in Toyota. So finding the waste into the system, and then cutting down these wastes was their motto, and that made 1991 this system, Toyota production system, as world-class manufacturing. Today, the lowest amount of waste can be found in Toyota manufacturing system, Toyota motor system, Toyota production system. And this system, they called it as a lean manufacturing system. So what is the requirement of industry? That we need to look at the performance parameters of the industry, any production system for that matter. And this is called as PQCDSM: productivity, quality, cost, delivery, safety, and morale. These are the parameters by which any production system can be measured for how is their performance. PQCDSM are the performance measuring parameters of the production system, and these parameters are required to be appropriately worked, monitored, controlled to improve the performance. In this case, productivity is required to be improved, cost is required to be decreased, quality is required to be improved, safety is required to be improved, morale of the people working in the organization required to be improved. So, what to do for this? And that is what, if you look at this too, so lean manufacturing, we wish to go for lean manufacturing. Unnecessary waste from the systems are required to be reduced. Hello, all participants are requested to mute their audios. So it is a continuous way of producing what customer wants. So, and everything to be less. Whatever resources you are using, man, machine, material, tools, equipments, money, matrix, whatever resources are to be used, they are required to be used for the less, as minimal as possible, so that productivity is improved, quality is improved, cost is decreased, and ultimately the profitability is increased. This is what is a concept of lean manufacturing. As I narrated, E.G. Toyoda and Taiichi Ohno, these two are, and Taiichi Ohno is probably called as father of the Toyota production system, lean manufacturing system. This system resembles with the just-in-time. They use the principle of just-in-time. So just-in-time is supplying the customer what exactly they want at what time. So when they want, we need to supply, like a Domino's pizza. So 30 minutes pizza at your home. So something like that, just-in-time. So whenever I need something, I can order and I am able to get that. So this concept is, there are two types of concept in lean. One, in manufacturing system, one concept is called as push type of system, another concept is called as pull type of system. So if I am producing something and giving it to the next operator, that becomes a push type of system. But the next operator is asking to give it to, and that is a pull type of system. And therefore, pull type of system is wonderful system, and this is being followed in lean. Just in time and pull type of system, single piece flow. These are some things which are used in lean system. So lean, as I said, is a wasteless system. So we need to identify wastes. So waste is anything that happens to a product that does not add any value from the customer's perspective. We need to look from the customer's perspective. What customer is ready to pay for? If he is ready to pay for that particular operation, he is ready to pay for that particular product, it is called as a value product. Otherwise, it has no value. And therefore, we need to understand, if it is having no value, it is going to be a waste. So, for example, if we keep some product into inventory, that is a product, customer doesn't want to pay for that. He is paying because he is being, uski majburi hai. But he is not ready to pay for it. So inventory, material transportation, inspection, all these are product waiting, material waiting. These all are wastes, and customer is not ready to pay. So we need to identify these wastes and try to reduce. From A to B, if material is moving in zigzag manner, probably the transportation cost is more. Material transportation from one place to other place, time required is more, cost is more, material handling cost is more. Instead of that, can we find a shortest path to take A to B material? So that path can be a lean path. Like that, we need to identify what are the various wastes. In lean system, they identified 8 wastes. Somewhere people call it as loss also, and they converted the 8 waste into 16 losses. But in lean system, there are 8 type of waste. 2013 prior, they had 7 waste, and 2013 onwards, now they call it as 8 wastes. And this can be with a synchronous downtime. D for defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, extra processing. So these eight wastes can be found in any system, and we need to reduce these waste. If possible, eliminate. If not possible, at least try to reduce to the lowest possible extent. So these wastes are what type of waste? Defect. What is defect? So defect we understand, a rejection. For that, what we need to have a rework carried out. So it is a 2-time cost. So whatever cost is there before producing the defect, this is one. So production of defect is one cost, plus rework is another cost of that. So what happens because of that? Normal continuous flow gets affected. It requires additional labor for reworking, requires additional material maybe for reworking. So what will we do for that? So we must create an SOP, standard operating procedure. We need to create defect possibility matrix. We can use a Pokayoke concept, that is mistake proofing concept. We can have a visual control, and by having visual control possible to have defects. So these are certain tools which can be techniques which can be used for reducing the defects. Similarly, overproduction, not required, but kept in form of inventory that I will need some days after. So because of that, I keep on producing and keep it in inventory. So this is cost to industry. So what it does for, what it costs for, uses extra space, requires raw material, utilities, transportation, scheduling cost, extra cost is required because I am producing too much. And because we are predicting that we will require this material in future, and for that we are keeping that producing and keeping into inventory. That is cost, that is a waste. We need to produce when customer needs, that is just in time. So what are the way outs for avoiding these type of defects? Reduce changeover time. Changeover time to be reduced from one setup to other setup. How can we reduce? There is one tool, what is called as SMED, single minute exchange time. Cell balancing using takt time. Single piece flow, no backtracking of the material, no second handling of the second material, no second handling. Only once it is to be handled. Whatever material you are processing, it should be handled once. So how it is to be done? Pull production system instead of push production system. Adopt pull production system, showing interest of the people, showing morale of the people, higher morale of the people that I am pulling the job to be done for. So morale improved. Waiting is another type of waste into the lean manufacturing system, in any manufacturing system for that matter. Operator remains idle for waiting for the next operation. So he is not getting the material from the previous operation, he is waiting for that. So what are the causes for this? Machine downtime, breakdown is there. Lack of parts, lack of availability of the parts. Long changeover time from one product to other product. Batch flow of the material. Because of the batch flow, changes of the batches, and because of that, the line is required to be waiting for. So what can be done for this? What are the various way outs for? We can have a wonderful work balancing. We can have setup time reduction. We can reduce the minor stoppage. Normally what is said in manufacturing is, if your assembly line stops for less than 1 minute, it is called as minor stoppage. If it stops more than 1 minute, it is called as major stoppage, breakdown as such. So find the minor stoppage and reduce them as minimal as possible so that the waste can be reduced, cost can be reduced. This is the waste added into lean manufacturing system after 2013, non-utilized talent. The potential of the people working in the organization is not appropriately understood, and it is being not utilized properly. The knowledge, skill, wisdom of the people working in the organization is not utilized properly. So what can be done for that? You can have a proper line organization balancing, understanding the skill set of the people. You can use skill matrix for that matter. You can use radar diagram for that matter. You can have a manpower assessment done for. And accordingly, you can allocate a job and allocate the work to a proper person and utilize his extent, potential possible, explore his potential. That is what you can reduce the waste. Another waste is a transport. Truly speaking, transport is the total transport is waste. But few transports are mandatory. You cannot avoid that. So they have to be, but they can be minimized. If possible, avoid, eliminate. If not possible, reduce. So because of the transport, what happens? You have a long lead time, large storage area required, scheduling problems are there, batch processing problems are there, poor cell design is there. Because of this, transport problem can be there. Poor plant layout can be another issue for transport problem. What are the various ways for doing this? You can have increase in the speed possible. You can use proper material handling system. Your production planning has to be proper. So logistic management has to be proper. So think, how can we do to reduce the transport issues? Sixth best is inventory. So how can we reduce inventory into the system? So what type of inventory we do may have? We may have a raw material inventory, finished good inventory, semi-finished good inventory, purchase, the standard product purchased good inventory, all this inventory. How to, what it requires? It requires cost, huge cost it is requiring. So if we adopt just-in-time concept, the inventory can go as zero as possible. This is what we think about, zero inventory system. But may not be possible to reach to that extent, but at least we can minimize the inventory to minimum level. So what to do for that? So inventory, you can use just-in-time concept, and you can use Kanban as wonderful system for the inventory reduction. So you can have a classification of inventory, that fast moving inventory, slow moving inventory. You can classify A type inventory, B type inventory, C type inventory, depending on the quantity cost. And accordingly, by this way, you can think about, and you can take a call that which type of inventory to be minimized. So how to do this? You need to adopt certain tools and techniques for doing this. Motion is another kind of waste, and this is huge waste. Bending awkwardly, reaching too far, excessive walking, lifting heavy loads, working unergonomically. That I am not using ergonomic sense. I am not using natural laws of working, human working in my operation, at my place, wherever we are. So what to do for this? I need to identify these motion losses. Where are the motion losses occurring in the shop, or wherever I'm working, in the office, in the production system, wherever motion losses are there, and how to avoid this? We can use motion loss reduction principles of motion economy. We may use most minor operation sequence technique system. So we may use many tools for identification of this. And using these tools, it is possible. Maybe a string diagram can be used, travel chart can be used, flow diagrams can be used, and by way of that, we can find where are the motion losses, and we can try to reduce these motion losses as minimal as possible. Extra processing or over processing. This is also one kind of waste. The operation which are required to be performed on the job, for which customer is ready to pay, but the operation which is not required. If I require grinding, do that. But if I do not require, milling is sufficient, only milling is required. Do that. So don't have any grinding carried out, don't have any lapping carried out. It will be costly, unnecessary, extra processing. So additional steps in manufacturing processes, extra material handling processes, not required at all. Reshaping a piece due to poor dies because of that. So removing burr, extra operation. Why we cannot do in the machining itself, removing the burr? Maintaining extra copies of information. This is what is extra processing. All the time I have to take it from drawer and I have to keep it again and again. So what can I do for that? So you can do combination of operations possible. You can eliminate what is that is non-value added activities. So you need to identify where are the value added activities, where are non-value added activities, and how can I reduce the non-value added activities. So these type of waste I need to identify. So where are the wastes happening into the system? These waste I need to identify and check. So what are the various causes for this waste, and how can I eliminate these wastes? So this is what is the lean manufacturing system, identifying the waste into the system. So for identifying waste, what can we do? We can have the operations carried out in the production system, identifying them as value added, that is called VA, non-value added, NVA, and necessary non-value added activities, NNVA. So what is this? Value added activity means what? Value can be simply defined as something a customer is willing to pay for the product or service. So If that activity is your customer is ready to pay, yes. For example, he is ready to pay for banana. He is paying 3 rupees, but the skin he is throwing and the core part he is eating, because he is not getting banana without skin. That is why he is paying for. He is not ready to pay for the skin because he is not eating that, and therefore the skin is a waste. It is non-value added activity, so it is a waste. Can we identify in manufacturing system moving from one machine to another machine? If an operator is moving from one machine to another machine without doing anything, is an non-value added activity. Customer is not ready to pay for that. So can we identify these non-value added activities? So we need to identify. If we complete this step, we can identify all non-value added activities in my entire industry. And if I can identify these value added activities in my industry, it is possible for me to see that these value added activities can be further strengthened. And I am differentiating between value added and non-value added. So I need to look at. So these are some value added activities. If I am doing drilling operation, the operation is value added. If I am welding something, is value added. When I go to an hotel, the food I eat is value added. But I am not ready to pay for the transport of the food. The waiter is bringing it from kitchen to my table. No, I am not ready to pay for. But he has to bring, and therefore I am compulsory paying. Can I reduce that? Can I reduce the distance between the kitchen and the serving table so that that can be minimized? Something like that we need to think about. And once we start thinking about these non-value added activities, we can find the waste into the system and we can try to reduce them. When I go to hotel, I am required to wait for my food to come. 10 minutes, 15 minutes, 20 minutes. And that is what is a non-value added activity. I am not ready to pay for it. But because there is a rush, I am required to wait for. All the time I want, the moment I order the food, I want the food to be served to me. But I need to wait for. So how much? If I am required to wait for more time, that is a waste. So I need to identify that this waste, how it can be reduced. Similarly in manufacturing, similarly in service. If you now we get money in ATM. Even if we go into ATM and the ATM machine is not working properly, I am required to wait for 2 minutes, 3 minutes. So if I am required to wait for 2 minutes, 3 minutes, I am not ready to pay for. I want my money to be urgently. So what to do for that? How to increase the speed of this? How to minimize this waste? And that is what is the challenge before all of us. Non-value added activities. Second type of activities are non-value. They are not adding any value into the system. For example, I am drilling. So I am having a step drilling operation. In the step drilling operation, first I am having a small drill and then I am having a large drill. So for small drill, after having a small drilling, then I need to remove the drill. I need to place the large drill into the spindle. This is tool change. And this time customer is not ready to pay for. This time there is no production is going on when I am changing the drill from taking out a small drill from the spindle, inserting a large drill to the spindle. Tool change time. It's a waste. What can we do? And therefore, can I do that? I can combine, I can create a step drill, and using this step drill, it is possible for me to make tool change time 0. I had been to the bank. This has happened to me. I had been to bank. I asked for my loan sanction letter. The clerk said, yes, wait. And he vanished from his place. After 2 minutes, he came down. He came to his place and he gave me a letter. I asked him, where you were? He said, the computer is on my table, but the printer is on first floor. So when he ordered printing from his computer, the printing was done at the first floor. So he was required to go to first floor to collect that letter, bring it here again and give it to me. Waste. So I need to identify. So what type of wastes are there? Certain value-added activities, certain non-value-added activities are mandatory. Necessary non-value-added activities. These necessary non-value-added activities you cannot eliminate. You can minimize them. You can reduce them. As I said, banana purchasing, the skin you are not ready to pay for, but mandatory, you cannot get banana without skin. And therefore, you have to pay for it. This is non-value added, but necessary non-value added. What next we can do? We can see the thickness of the skin and we can minimize that thickness while purchasing the banana, and we can reduce that waste cost. Same phenomenon. So whatever activities are there in the shop floor, the transport between the machines is non-value added activities, but mandatory. What we can do, we can minimize the distance between the stations, and by that way we can reduce the transport cost. So necessary non-value. For example, I have a fire extinguisher. So fire extinguisher purchased by me, after 2 years I need to refill it. It's a government norm. So I did not use that fire extinguisher for 2 years. I did not require. But after 2 years, I need to refill it again. And therefore, that cost is non-value added, but mandatory. So government norms, rules, regulations, and these are mandatory costs. So you need to differentiate between what are the value-added activities, may it be industry 4.0, any industry for that matter. So you need to identify. When you are carrying out automation, whenever you are carrying out something where you are using the cyber physical systems, you need to identify what are the non-value added activities. What are these non-value added activities? Are they mandatory, necessary? If they are necessary, I can minimize them. And if they are not necessary, I need to eliminate them. So that is how we can see that combination to occur for. So lean manufacturing system, wonderful advantages it has. So it increases the productivity, and that is what is our aim is. We need to increase the productivity. Reduced amount of floor space. Space productivity is improved. Almost all lean manufacturing system try to go for, instead of I layout, they try to go for U type of layouts for machining. So for assemblies. So because of that, what happens is the space requirement reduces. Reduced manufacturing lead time, because you are going for just in time. You are eliminating the waste from the system. Manufacturing lead time is reduced. Processing time itself is reduced. Transportation time itself is reduced. Waiting time itself is reduced. And the product of these three is lead time. Improved flexibility to react to the changes. So whatever changes are happening around, flexibility is there. The quality is improved, and in turn, cost is reduced. But what happens is limitations. There are certain limitations. So difficulty involved with changing processes to implement lean principles. It is difficult to. Identifying the non-value added activities requires observations, requires manpower for that matter. Long-term commitment required. Implementing lean once doesn't mean that you are implementing it like you are changing it for lifetime. No, you need to continuously keep on. Lean has one principle which is called as continuous improvement. Truly speaking, it is continual improvement. So we need to keep on improving. And therefore, one-time implementation doesn't mean that you are going to get the benefits. You may, but if you want to get the benefits continuously, you need to have continuous improvement. This can be risky also. Why? Because if you go for just in time, and if you cannot satisfy the customer just in time, likely possible you may lose the customer. And therefore, you will have to take a call, balance between what is the current scenario outside, what is your current time, and then accordingly you need to implement a lean. There are many industries, as I said, Toyota, John Deere, Parker Hopkins, Intel, Caterpillar, Nike in India, Bharat Forge, and many industries are there who are trying to implement the lean system and getting wonderful results. Probably right now, for last 5 years down the line, if you look at, healthcare system is trying to. All big hospitals are trying to implement this lean manufacturing system so that their cost can be reduced. And that is what. So food industries are trying to implement the lean system so cost can be reduced. So there are certain tools and techniques which can be used for the lean manufacturing system. So these are general tools I am depicting here. So these are general, but there are certain tools and techniques which are used in lean, particularly developed by the lean manufacturing system. And these are the lean tools and practices looking at the objective to be achieved. So I have an objective. I want a supply relationship, wonderful supply relationship. I want to use my human resources to the maximum possible extent. Manufacturing, I want to have a wonderful planning and control for manufacturing and processes equipments to be utilized to the maximum possible extent. For these, they have developed certain tools, certain practices for. So what are these tools and practices? Supply relationship, supplier quality, lean supply chain, just in time. For human resources, workforce commitment, employee employment, quality circles, manufacturing planning and control, leveled scheduling, Hijunka is called, visual control and on, Kanban, full production system, workforce engagement, and process and equipments. So whatever the layouts are there, assembly lines are there, equipments are there, machines are there. For that, what are the various tools they have, techniques they have developed? Cellular manufacturing, Six Sigma, Lean Six Sigma as it is called. Continuous flow, single piece flow, continuous flow. Continuous, no backtracking of the material. Waste identification, reduction. Pokai okay. Pokai is mistake, yoke is proof. So even if I do it intentionally or unintentionally, not possible to have any mistake occurring into the system. VSM, value stream mapping. TPM, total productive maintenance. Kaizen, continuous improvement, continual improvement. 5S and SMED, single minute exchange time. So these are certain tools developed by the lean system. And what I'm looking at is application of these tools into industry 4.0. Or industry 4.0 collaborating with these tools so that again productivity can be improved. Again, cost can be reduced. So these are certain tools. These are certain tools developed by the or used by the lean manufacturing system. 5S and on bottleneck analysis, continuous flow, Hijunka, Jidoka, automation, just in time, Kaizen, Kanban, 3M, Muda, Mura, Muri, overall equipment effectiveness, OE, wonderful tool. This can be applied even to the hard automation systems. Means a computer, a cloud system where I can use this overall equipment effectiveness, PDCA, Plan Do Check Act, okay, error proofing, mistake proofing, root cause analysis, YY, single minute exchange die, total productive maintenance, value stream mapping, visual factory. These are certain lean tools and practices. So what are they? If you make efforts plus tools, you are going to get results. If I want to tighten the screw, I need to. So the effort to be made for the tool. But if I use a wrong tool, probably you are not going to get any results. So I must use effort plus correct tool. If you use this combination, effort plus correct tool, the results are going to be wonderful. So what is that? So what are the various tools I am talking about? 5S is wonderful tool. Sort, set in order, shine, standardize, sustain. This is what they could see in Piggly Wiggly. Whatever you need, keep it. Whatever you do not need at the place, remove it out. Whatever you need, that is called a sort. So first waste you eliminated. Whatever you need for your working, at that point of working, keep that. Install is not required. They apply a rule, what is called as 48-hour rules. If you don't need this material for 48 hours at your workplace, probably this doesn't belong to you. Keep it away. Keep it in the store. And if at all not required, throw it from the factory itself. If required, so somewhere else, give it to someone else. So that is what? Set in order. So a place for everything, everything at its place. If you read a story of Napoleon and Duke of Wellington, Napoleon was beaten once. Napoleon Bonaparte was beaten once in the battlefield. And the person who defeated him is Duke of Wellington. And Duke of Wellington was asked, what made you to defeat Napoleon Bonaparte? And he said, there are two things for this. One, I reached the battlefield half an hour early than Napoleon. That is first. And second, he said, I had everything at the place I wanted it for. So whatever animations required, food coherence required, everything was at the place required for. And that is what is set in order. So we must keep the things in the proper sequence. A place to be created and to be kept in the place, picked up from the place, work for the place. That is second order. Kept in clean condition, that is shine. Third, we need to have a standardized practice for that. We need to create a cleaning schedule. We need to create an inspection schedule, and we need to follow that. Then only they will remain at the place where they are supposed to be. So they are available. We can pick them and work on them. And sustain, we need to have a practice for this. Once it is not to be done, we need to inculcate in form of habits. So that is what is the 5 years. They worked on this 5 years, and almost in Indian circumstances, if we look at last 30 years, many of the industries implemented these 5 years and wonderful results they have got. Second is hand-on. So hand-on is a visual factor. Initially, what was happening? Line stopped, line breakdown. People were running here and there. They were not getting any signal. So can you use signal? Line is working green. Line is in something to be told, meeting has to be arranged, yellow signal. And line has some problem, red signal. It indicates. Now you get visuals. And by that visual, you can interpret and you can accordingly work. So can you think about this visual? One part of the story. Continuous flow. We need to have a single piece flow. From A to B, B to C, C to D, the continuous flow has to be there. From B to C to A, material should never come back. If it comes, it is loss. It is called a hidden loss. Backtracking of the material. Multiple handlings of the material. So how can we do that? How to get that continuous flow? Then single minute exchange dies. Single minute exchange dies is a wonderful tool. Probably you may wonderfully listen to me. Wonderful, you may feel wonderful that the die time required in Toyota, changing dies from one product to other product, the time required was 240 minutes, 4 hours were required for changing the dies, and production was stopped for 4 hours. A person known as Shingo came into picture. He studied that process and he developed this technique, single minute exchange die, and he brought that die change time from 240 minutes to 3 minutes. And that is why he please mute. And that is what he named that. Hello. Please mute your audios. So, and that is why he named that technique as single minute exchange die. So die changing time I can bring less than 10 minutes. That is in a single digit. 3 minutes, wonderful. 237 minutes waste eliminated. Can we think about in the process for setup change? How can we reduce the time required for? So identify all non-value added activities and reduce the time by doing this process. If you look at the picture, you will find the material not kept properly. If material is not kept properly, you need to work for. And if it is kept in proper sequence, that first is removed and second is inserted. Enough. And that is what you need to identify a single minute exchange die. Hijunka, a wonderful tool. That we do have a demand for our product, which is fluctuating demand. In seasonal products, this happens. Even if in continuous production also. If I am producing vehicles, I know that in Diwali season or Gudi Padwa season, I will have a maximum sell. And after that, it is going to drop down. So there is a fluctuation. So what should I do with this fluctuation? How should I work with the manpower required for producing? How to calculate that? And for that, you can use this Hijunka tool. And you can label the production. Keep on continuously producing that quantity so that you are not required to have any effect on the manpower, or you do not have any effect on the material and all that. So a production technique to level the workload and create a smooth workflow. Wonderful tool it is. Jidoka, autonomization. So a tool for automation, sort of automation. So partially automation. Manufacturing process, I need to automate. How to use this automation? How to use this low cost automation? Jitoka. Just in time, as I said, I need to produce when it is required. So calculate. Wonderful in Indian circumstances, if we can talk about, there are many industries who are using this concept. They have not reached to 100% just in time, but to some extent they have reached. Many industries have reached to a range, percentage of 80%. Once upon a time, they were producing 100% inventory, keeping it for 2 months, 3 months, 4 months. Now they have inventory of almost 8 days, 10 days, and they want to bring it to 3 days. So you can look at how to achieve this just-in-time concept. Kaizen is a wonderful tool. Continuous improvement. A small change that can bring a large improvement into the system. All people working in the organization cannot be innovators, but they can be people who can have a small improvement in their work area. In terms of man, machine, material, method, equipment, tooling. So how to use that? Small group activities. How can we use these small group activities so that they can work, they can create a better scenario? So change for good to happen, change for better to happen. There are almost 19 types of the Kaizen people are using around the world. So how to use, which type of Kaizen to be used, where is Kaizen to be used, and how we can get the results out of this Kaizen. Value stream mapping, and wonderful tool from upper supply line to down supply line. That is from supplier, raw material supplier, within my factory, the material movement, and then making this final good to reach to distributor. This is what is my chain, supply chain. Raw material from the supplier, standard components from the supplier, bought out components from the supplier, semi-finished component from the supplier, plus the machining or operations carried out in my factory, the material movement within my factory, and after that, finished good, reaching to the distributor. This is my supply chain. I need to mark how this material is moving, how the value is added within this chain. And then I need to identify the waste in the chain and how can I reduce that. So for that, value stream mapping is wonderful tool. So how can I use this value stream mapping? Kanban, another tool which can be used in pull type of systems. So I said lean is a pull type of system, not push type of system. So in this pull type of system, what to do? Initially, inventory was in very large quantity. So how to reduce this inventory? And I should not suffer from non-having materials. If I bring inventory to zero and machine breakdown happens, then I don't have material or something like that. Then, so what to do for that? Then I need to calculate how much is minimal required, and I can create a tray for that. So I can create trays for that. So material comes from supplier keeps it to the store, and the factory takes from that store. And this bin, which is at the store, is indicator. The moment there is a end of the material from the store bin, supplier is instructed at one level. Supplier gets instruction that he needs to supply. So if suppose I have 500 pieces and I say that my buffer stock is 100, so 500 pieces kept in the store in the bin. So as soon as level of 100 is reached, supplier gets an intimation. Supplier starts producing and supplies the next lot of 500 pieces, 400 pieces, and keeps it into the store. Same way. So can we use this type of Kanban system, which will ensure that we are having a pull type of system, waste elimination in material transport, inventory. So can we think about overall equipment effectiveness, OEE as it is called, a product of availability, performance into quality. If we take for that matter an hard automation system, a computer system, automation system. So what is availability of the system, what is performance of the system, and what is quality produced by the system? A product of these three is called as OEE. 1980s or 1990s, around the JIPM, Japanese Institute of Plant Maintenance, has finalized 85% if you get for any machine, that is called as world class. But the definitions are required to be changed now, because many industries are there where they are getting an efficiency of 90, 95%, 96%, 98%. But there are many industries where I visit for and I can find that the OEE of the machines is around 30%, 35%. 65% efficiency effectiveness is vested for. You can look at the in automation also. You can look at the computers we do have. So what is availability is 100%, but what is the use of that? So we can find out the losses created into the system and we can improve this OEE, overall equipment effectiveness. You can find it. One of the industry which I work for, so they had a 30% OEE. Now in 6 years span, they have reached to a concept of 93% of the same machine. Tremendous reduction in the waste, tremendous reduction in the cost, tremendous improvement into the productivity. What is to be thought about? So we need to identify the losses, 6 big losses. Wonderful tool. Identification, practice. So what are the losses? Equipment breakdown, setup losses, minor stoppages losses, speed losses, startup losses, reject losses. That is the quality loss. So we need to find these losses and how can we reduce these losses so that my equipment efficiency improves. So identifying the losses and working on 3 M's. Muda, Mura, Muri. Identifying this. Muda is a 7 type of waste, 8 type of waste. So whatever wastes are there in the factory, I need to identify. What is Muri? Muri is unreasonable burden. One worker is given 60-minute job, another worker is given, one worker is given tremendous load, another worker is not given. So that unbalance is the Mura. And stress, very stressed worker, very stressed operator, very stressed supervisor, very stressed person. So that is what is the Muri. So can we identify this? Where are the 7 waste, 8 waste occurring? Where is the unreasonableness with the work allocation to the people? Where is the unbalance going on? One is given 60-minute job, another is given 58-minute job. 2 minutes unbalance. Can we give 59, 59? So looking into this, and one more tool is Pokayoke. As I said, mistake proofing. Look at it up. You cannot. If there is a 3-pin, 3-plug pin, you cannot insert in any other way possible. 2-plug pin, you can insert. But if you design like this, in the picture shown, not possible. In any other way, it cannot fit. Microwave, you cannot operate without closing of the door. Unless the door is closed, microwave cannot be made on. And this is Pokayoke. Even if you want intentionally, unintentionally to start, it cannot. So think, how can I do this? There are many types of Pokayoke, shutdown Pokayoke, control Pokayoke, or alarming Pokayoke, warning Pokayoke, and so many types of Pokayokes are there. So using these sensors possible on the shop floor, and it helps you to improve the quality of the product you are going to produce for. You do not allow the mistakes to happen. And by way of that, quality is improved. And in turn, cost is reduced. Root cause analysis, wonderful tool. Any process, any wrong thing happening on the shop floor, any waste happening on the shop floor, any loss happening on the shop floor, I need to ask. There are 2 solutions to any problem in the world. One solution is temporary solution. If machine is stopped because of something, I can find bearing is jammed because chips are there in the bearing. So I can take out the bearing, clean the bearing and start the machine. That is temporary solution. But I need to find why chips are going into the bearing. I need to ask the questions, why? And I need to reach to the root cause. And I could find that the bearing was open because of which chips were entering into. So what should I do? I can keep a cover to the bearing or guard to that. And then the chips will not enter and machine will never come to breakdown. So I need to, what is that root cause analysis? For any problem, I need to have a root cause analysis. Keep on asking why. PDCA, plan, do, check, act. So what I am required to do for, I need to plan. I need to keep on doing. I need to check whether I am working as per the plan. And then I need to act if there is any gap. And this is what is a wonderful tool given by W. Edward Deming. So Deming cycle as it is called as. So can we use this? Total productive maintenance, wonderful tool. This talks about the operator doing maintenance of the machine himself. Prior to TPM, people used to say, operator used to say, operator, I'm saying anybody, in any manufacturing, production, service, anywhere it is. So he used to say, suppose a Xerox machine is there in your office. The operator says, I do. And he says, shows the finger towards the maintenance man. He will maintain. But instead, TPM has brought a significance. He has brought, the TPM's philosophy has brought a concept saying, I operate, I maintain. The person who is working as a Xerox operator can do the Xerox also and can do a little bit maintenance of the machine, learning of that. Small cleaning, small inspection, small tightening, small lubrication can be done by him, and the life of the machine can be improved because he knows his machine well. So this sort of TPM can be used. So I have to use this concept. And wonderful reduction in the breakdown and cost. Visual factory. The last tool is visual factory. As far as possible, this is wonderful tool. As far as possible, we should look at the visuals. We should think what visuals we can make use of, how visuals we can make use of, visual indicators, visual displays, visual controls. If we can make use of these visuals maximum possible, probably many wastes can be reduced. And these are the tools which can be used in the lean manufacturing system. By using these tools, it is possible for us to reduce the cost. And now, how this combination to occur? Lean and Industry 4.0 philosophies are often complementary. They are not apart from each other. They are complementary. I can use Industry 4.0 into the lean factory, or I can use lean into the industry which are implemented Industry 4.0. And I can have a collaboration of this. And probably we want to reach to a stage where we do not call it a lean industry 4.0. Instead, we call it a lean 4.0. So a collaboration to occur. So what is possible? Over the last decades, the manufacturing sector has experienced a transition from craft production into mass production, we all know, and mass production to lean production. Everybody is trying to reduce the waste. So lean is recognized a best practice in these days. But traditional production system, we know that we want to implement automation. We want to bring Industry 4.0. So for bringing that, we need to implement the IIoT, industry internet of things, big data analytics, additive manufacturing, augmented virtual reality, cloud computing, machine learning, artificial intelligence. We want to implement. So will Industry 4.0 replace lean, or will they coexist? That's a question. Are lean and Industry 4.0 technologies compatible and share synergies, and are they divergent to each other? In other words, the overreaching question is, can lean keep up with the digital era and evolve into lean Industry 4.0 or lean 4.0? That's the question. In manufacturers, if manufacturers adopt a lean methodology and Industry 4.0 separately, suppose I have an industry and I am adopting lean. By adopting lean, I may get certain benefits that may extend to 15%, 20% reduction in the cost possible. If I adopt to Industry 4.0 automation, I may get the reduction in the cost maybe 20% possible. But if I adopt both of them, ML, AI, CPS in the industry, lean industries, machine learning, artificial intelligence, cyber physical systems, Internet of Things, if I adopt them into the lean manufacturing system, likely possible that I can get a 40% reduction by this combination collaboration. Individually, I could get 15-20% reduction. But if I use a collaboration of these two, likely possible, I can get 40% reduction. This means that combining lean and Industry 4.0 yields a 100% increase, likely possible. And people are trying. There are few examples, few case studies. A food industry is a wonderful case study that has got the reduction by 40%. So Industry 4.0 paradigm centers in deploying advanced technology to develop integrated and highly adaptive manufacturing system and supply chains. We know the benefits associated because it is a highly automated system, and therefore we are going to get revenue gains, increased efficiency, productivity, machine downtime reduction, faster cycle time, improved supply demand matching, improved product visibility, traceability. That is okay. But lean industry is a people-centric system. It is involving people to work for, doing Kaizen, doing 5S. So this is people task, group task. So how this can be combined? So lean is a technology adversely which philosophy centers on the people, processes, and a culture of continuous improvement. So we feel that are they diverse? Industry 4.0 is technology driven, lean, people driven, people centric. So are they divergent or can they be convergent? And that is what is the question, and that is what we need to think about, and we need to collaborate. And I'm sure that this collaboration will work. So why it will work? Because we know even if we go for industry 4.0, we cannot eliminate manpower to work. 100% elimination of manpower is impossible. We cannot reach to a dark factory system sitting at my home. I am operating entire factory for my mobile without a single man operating to the system. That may be a dream long term. 100 to 100 years, I don't know whether it will come into existence or not. People are trying. One of the chemical industry is being tried for this part, dark factory. But sure about that, manpower cannot be totally eliminated. And if I cannot eliminate manpower working into organization, therefore their lean possibility exists all the time. For hard automation, industry 4.0 can work for, but where people come into picture, lean possibility can work for. And what can it, how can it work? I have a Kanban system, hard Kanban system. So I am keeping beans, I am keeping beans, and supplier is supplying material into beans and the manufacturer is taking from that bean. So this is hard. Can we think about having a e-Kanban? And that is what is being used in industry right now. Instead of having a hard bin, can we have a e-Kanban? That entire supply chain operated through a software. The moment I reach to 400, so I need 500 pieces and 100 is my buffer stock. The moment 100 it reaches to 100, immediately an intimation goes to supplier software through software, and supplier starts producing. Now he is not required to look at, he is not required to have any hard call to be made for nothing. And this is e-Kanban. So using this automation and Kanban, combining them together, converting them into e-Kanban, we can get the maximum benefits of Kanban plus automation both, and we can get possibility that productivity still further can be improved, cost can be reduced. Same way with the VSM, value stream mapping. Instead of doing it in a hard way, can we do it in soft way? Can we do that in soft way? Possible. And doing that EVSM, so likely possible, we can make use of. In the same way, industry 4.0 technologies may require some lean solutions to adopt to be able to support and coexist with such technology. Whereas in some cases, use of the industry 4.0 automation can be used into the lean so that both can collaborate and we can get highly digitized and automated production environment. With help of this, we can reduce the cost. So I said, whether lean and industry 4.0 paradigms are compatible, synergetic, I say yes. Lean and industry 4.0 technologies are often not only compatible, but also complementary due to synergies they share. This offers companies opportunity of achieving higher levels of efficiency in the production systems and supply chains. How it can be? I can have just-in-time and digitization of supply chains. Just-in-time coming from lean, digitization coming from industry 4.0, and I can have a digitization of entire supply chain, and this can improve the productivity. automation and cyber physical system. So Jitoka and cyber physical system. So I want to have automation. I want to have the maintenance. I want to have the automation, and I am using a cyber physical system to create a more automation to this system. Root cause analysis can be done by the automation process. This is cyber physical system. Instead of doing it manually, I can create a software for that, and cyber root cause analysis can be made, root cause can be found and worked upon. Break. Total productive systems can be, total productive system, as I said, is a self-maintenance system. So can I use virtual augmented reality, machine learning, and big data for that? So I can understand from big data analytics. I can understand what are the reasons for failures, and for that I can understand the abnormalities in the machine and lines, and by using that I can eliminate. So TPM coming from the lean, and augmented reality, machine learning, big data coming from the industry 4.0. Value stream mapping replaced with help of the RFID or Internet of Things, by which the waste identification can be done and can be eliminated. Hijunka and big data analysis. Right now I am doing manually. Instead of that, can I do with this big data analysis? Can I have an smoothing of the production schedule? Can I calculate how much to produce every day, so that I am not required to have any retrenchment of the manpower, and I am using that manpower to the maximum possible extent, and inventory as minimal as possible. So using Hijunka from the lean and big data analytics from the machine industry 4.0. Similarly, many tools can be made use of. Many people who are working into industry 4.0 can be given the tasks of SMED, can be given tasks of Kanban, can be given tasks of Kaizen, and the system can be improved. So using this, you can find that it is possible for us to improve the productivity further by implementing both, complementing both. So you can look at it. So industry 4. Industry lean industry getting 15%, 20% cost reduction. Industry 4.0 alone 10-15% cost reduction. Industry 4.0 with the lean. So appropriate sensors use, appropriate big data analytics use, virtual reality, augmented reality, Kaizen, e-Kanban, VEVSM, and all that. Using that, it is possible for us to get the 40% cost reduction. And this has already been, this is already been done in one of the food industry, and many industries are trying for this. In Germany also, 100% industry 4.0 is not there. 55% industries have done, and this is mainly applicable where you need to come down to. What I am suggesting here is industry 4.0 automation is too costly system. What will happen to these MSMEs, small OEMs? They cannot afford 3 crore, 5 crore, 10 crore investment. They cannot afford, but they can afford lean. But can we reduce the cost of this industry 4.0 to some extent and make an amalgamation of this, collaboration of these two, and use this for the maximum benefit of OEM? And this is what is the challenge, future challenge for the systems. There are certain objections. There are certain things, differences between industry lean and 4.0. So converting industry 4.0 into lean is not possible. Lean converting into 4.0 exactly entire not possible. But we can try to have collaboration of these two, taking advantage of these two. Working with people, as I said, use of computer, industry 4.0, working with people for lean manufacturing, and therefore they seem to be divergent here. This is a difference, but believe me, industry 4.0 cannot replace manpower. Lean 4.0 cannot avoid automation to come. Lean cannot avoid automation to come. Industry 4.0 cannot avoid the manpower, people to work. And therefore, combination can be made use for. Speed of change, that is huge difference. Japanese people adopting lean, they can use any solution. It may be smart solution, it may not be smart solution, but they want at that time solution, and they go on, they keep on working with that solution. Quick fix solution, as they call it. Industry 4.0 always wants a smart solution. This is what is the speed change. This is what I want: faster, smarter. Lean is quick fixer. So however that solution is, however bad that solution is, so can this be worked out? And flexibility. Industry 4.0 is not a flexible system, rigid system as it is. Lean system is flexible system. Can we have this flexibility combined? Can I make this pyramid to move 3 meters? I cannot. And therefore, lean industry 4.0 is slightly a rigid system. Lean system is a flexible system. But can we make a combination of this? Can we create industry 4.0 to suit to the flexible system, and particularly to suit the small scale industry or OEMs, and have the lesser possible cost? So how the industry 4.0 we are looking at? Are they separate? Are they divergent? Are they contradictory to each other? Is industry 4.0 is subset of lean? Is lean subset of industry 4.0? I do not agree with all this. What I agree is lean and industry 4.0 can collaborate, and in days 2 we can reach to lean industry 4.0 or lean 4.0. This is what we need to think about and implement for. I sincerely thank the organizers, Field Mechanical Engineering Department, Secretary sir, and all for giving me opportunity. I thank you for all listening patiently. Now, if you have any questions, please feel free to ask. So we have a question answer time. So feel free to ask the questions if you have anything to ask for.
Thank you very much, Professor Dr. Tated sir. Wonderful
Yes,
session, an intellectual treat to all of us. Participants, if you have any queries, please go ahead.
Umesh, any question? Sir, I want to ask one question. Tated
yes,
sir.
please. Yes, please. Yes, please.
Yes, Kulkarni here, sir.
Oh, wonderful. Good morning. Yes, very nice.
Yes, we were talking about the just-in-time technology.
Yes.
Reducing the inventory. But that reducing the industry is good for the large-scale industry. What about the vendors which are supplying the products to the large-scale industry? They have to just make a stock of that. So
yes,
just in time is good for one industry. At the same time, it is worsening the small scales.
Okay.
Now, so what is the solution for that? It cannot be a common good thing for all the industries.
Yes.
Industry must share the inconvenience.
Yes.
But in this JIT, just in time technique, larger industry, बड़ी मछली छोटी मछली को असं काहीतरी वाटतंय मला त्याच्यात. तुम्ही सांगा ना त्याच्यामध्ये काय ते.
Now listen, I never said that just in time can reach to zero inventory system. Not possible.
Yeah.
Even Toyota today also has not a zero just in time.
Yeah.
But what can happen is we can reduce the level of the inventories by adopting just in time.
Yeah.
Concept is not the target is zero.
Yeah.
Benchmark is zero, but we cannot. Even if we take an example of Maruti today, Maruti has reached to 80% of the just in time. Does mean that 20% they are keeping inventory.
Yeah.
Now they will have to collaborate with their vendors, suppliers, and they will have to check. What happens is small scale supplier problem is with OEs, overall equipment effectiveness. They have problem with the breakdowns, and for avoiding these breakdowns, for avoiding the delays in the breakdown, they keep on inventory. So they feel कि machine बंद हो गया तो I will need.
Yeah.
And if they work on this, that is what I said. One of the industry where the OE was 30%. So 30% OE, 70% West. 70% time it was a breakdown. So he was keeping inventory of 3 months.
Yeah.
3.5 months. Now when his OE increased from 30% to 93%, now he is keeping inventory of 15 days.
Yes.
So there are other factors also to be looked into. Just in time is a concept, but for that other factors also to be looked into. So you need to reduce the losses, you need to reduce the motions, you need to create layouts, you need to. And by that way, you can keep on reducing the inventory. That is possible, absolutely possible. For example, अगर हम आपका घर का ही example लेंगे, तो एक वक्त था कि एक ही किराना शॉप था, इसलिए हम साल भर का मटेरियल लाके रखते थे. लेकिन हमारे घर के आजू बाजू में अगर 4 मॉल हो गए हैं, तो हम साल भर का नहीं भरते. अभी 3 महीने का लाके रख सकते हैं, इनफ. 2 महीने का लाके रख सकते हैं.
Yes.
If availability goes on increasing, availability of the system goes on increasing, and it is possible that we can go to zero inventory system. But that is target. So still, is a Toyota के पास भी inventory है. Toyota also is keeping inventory, maybe of 8 days. Yes. But once upon a time it was 3 months, 4 months, no? So 4 months came down to 8 days is wonderful phenomenon. And that is exactly what we need to talk about. So OEMs also can do this. Even if they implement 5S, even if they implement VSM, even if they implement continuous improvement Kaizen, even if they implement small sort of automation, possible for them to reduce the inventory to the minimal possible extent. Absolutely possible for them. So in this way, we'll have to work. They have to collaborate. And Maruti is very wonderful in that. Maruti chain is very wonderful. You study this Maruti system and you will find that Maruti is able to launch every 2 months one product into the market. How? जितने प्रोडक्ट्स मारुति लॉन्च करता है इंडिया में अभी भी कोई नहीं है उतना प्रोडक्ट लॉन्च करने वाला, क्योंकि मारुति इज वर्किंग विद द वेंडर्स एप्रोप्रिएटली and they try to situate the vendors within Manesar area so that the transportation cost is reduced.
Yes, sir.
So this is how we need to work for. Yes, absolutely. Very nice question. Thank you very much. Thank you. Yes. Any more question?
Thank you, sir.
Thank you very much.
Is there anybody who is having some queries or questions? So today's lecture is full of variety of fruits in one basket breakfast for us. Sir has given overall first what is lean, what is waste management, what are the different techniques which are used in this lean. This is something like refreshing our knowledge. Again, how this lean, which is basically people-driven type of thing, and Industry 4.0 is technological-driven type of thing, and how these two systems are going to collaborate in future. What are the causes of that? What are the objectives of that? And all these things Sir has elaborated with a very nice thing, and again, that such type of lots of differences between lean and Industry 4.0 is nicely delivered by the sir. So thank you very much on behalf of Mechanical Engineering Department, Government Polytechnic Nanded. Again, Sakalkar sir, our beloved principal, Dr. Garje sir, Kulkarni sir. So thank you very much, sir. Again, in future also, our department would like to have such type of nice session with you, sir. With your kind permission, I will say today's session is over. Thank you very much, sir.
Nice of you. Thank you very much.
Thank you. Thank you, sir. Good day, sir.
Good day.
Yes.
Thank you, sir. Thank you, Tated sir. Sakalkar here. For participants, please join dot at 1 o'clock. Our honorable principal will be speaking on national education policy. Attendance of everybody is rather compulsory, I would say. He would enlighten on various aspects of national education. Thank you very much.